Hello and welcome. Here is an example of Thevenin's theorem. Thevenin's theorem states that a linear two-terminal circuit can be replaced by an equivalent circuit. Thevenin equivalent circuit consists of an independent voltage source Thevenin in series with a resistor R Thevenin. As we can see, this theorem provides replacing a given network by a single voltage source with a series resistance. It makes the solution of complicated networks quick and easy. Before we proceed to the computation of Thevenin resistance and Thevenin voltage, we need to know that the Thevenin voltage is same as the open circuit voltage in the original circuit, or Thevenin is equal to VOC, while Thevenin resistance, or TH, is the ratio of an open circuit voltage to the short circuit current, as the formula given. In this theorem, we need to compute the equivalent resistance and the equivalent voltage. To compute the equivalent resistance, first of all, we need to remove the load. Cancel all the independent voltage and current source and compute the total resistance. To compute the theorem voltage, we need to remove the load. Then, define the open circuit voltage VOC across the open load terminals, and then solve for VOC. Let us see the example to understand this theorem. So the question is, find the Thevenin equivalent circuit of the circuit shown. This means that we need to find the equivalent resistance and the equivalent voltage. To find the Thevenin resistance, our load need to be removed, and we can see here there is no R load. And then cancel the voltage source and the current source. The voltage source is replaced by short circuit and the current source is replaced by an open circuit. As we can see, there is no current source here. In order to calculate R Thevenin, we need to start from the side that opposite to the side of the removed load, which means this side. So start by calculating the equivalent resistance. We have 4 parallel to 12, so the resulting resistance will be in series with the 1 ohm resistance. Therefore, we write 4 parallel to 12 plus 1, and the equivalent resistance is 4 ohm. Now, we are going to find the Thevenin voltage. Thevenin is the open circuit voltage in the location of the removed load. We can simply cancel this resistance because there is no current flowing in this resistance because this terminal is an open circuit. We can see that Thevenin is parallel to the voltage here, and that's why we call the voltage here is Thevenin. This means that we need to find the voltage and this resistance, or Thevenin, in order to find the voltage here. To solve this, mesh method or nodal method can be applied. First of all, we need to define the currents in I1 and I2. Now, we need to write the equations for I1 and I2. Let's start with I1. So, we write 32 minus 4I1 minus 12I1 minus I2 is equal to 0. Since we have current source in I2, we can directly say I2 equals to 2 ampere. But since the direction of I2 is opposite to the direction of the current source, we write I2 is equal to negative 2 ampere. By substituting this value and this equation, we get the value of I1, which is 0.5 ampere. Since we have I1 and I2 now, we can find the Thevenin voltage. Thevenin is 12. the value of resistance multiplied by I1 minus I2 because I1 and I2 contribute in the current flowing, and the 12 ohm resistance, and by solving we get the voltage, which is 30 volt. We can also solve this theorem using the nodal method. We can see that we have only one node here that need to be solved, so we need only one equation to find the Thevenin voltage. Now we need to apply current voltage law, KCL, to this node, and we can write the following: 32 minus V Thevenin over 4. The 2 ampere current is also entering the node, so rewrite it in the same side of the equation. The current that flowing in that 12 ohm resistance is leaving the node, and that's why we write it on the other side of the equation. The value of this current is V Thevenin minus 0 because this is the reference node or the ground node, so V Thevenin minus 0 over 12, or simply V Thevenin over 12. And by solving, we get V Thevenin, which is 30 volt. So we obtain the same answer as the mesh method. Now we have the Thevenin voltage and Thevenin resistance. Therefore, we can replace the entire circuit diagram with a voltage source and the series resistor. So the value of V Thevenin is 30 volt, and the R Thevenin is 4 ohm as obtained from the previous step. That's all. Thank you.